Take some questions on this. We just went over the answers to this worksheet, and Nicole, which one? Number 3. Okay. And there may be some on here that may not be on the test, and so if I see them, and if I see a problem that you're not going to see anything like that on the test, we'll just look at it and skip over it, okay? But I think most of these you probably will see. Well, just ask me questions, the ones that you have questions on, and then if they're going to be on the test, we'll go over it. If not, then we won't go over it. 9. Okay, and these should... Okay, don't just start listing every one of them off. I mean, these should be problems that you worked on, that you tried, and you just can't get, all right? If you didn't try them, don't even ask about a question. If you didn't even try it, because I've given you, what, I gave you all weekend, plus I gave you yesterday, and if you didn't even try it, then, don't even ask about it. But if you do have questions, and you tried it, then I'll be happy to go over them with you. All right, so number 1, you said? Number which? 18? Okay. Anything else? Take a look at it if you had a question on one. 7. Okay. All right, let's start on these. If we have some time and we want to do some more, we can do some more. All right, let's just go in order. Let's do number 1 first. All right, it says of 300 television sets sold, and you will have one that looks something like this. Okay, it's not the exact same problem, but it's very, very close to it. Okay, so you will have one like this problem right here. 300 television sets were sold. Last month, 90 were flat screen TVs. What's the ratio of flat screen to the other TVs? Okay, now watch. There's 300 TVs sold, right? If I can spell right. 300 total were sold. And that says 90 were flat screen. All right? So what does the question say? It says, what is the ratio of flat screen? So watch, we're going to do a fraction here. A little straighter. Of flat screen to what? What's it say? To the other sold. To the others. We'll just put others. Okay, so let's put some numbers in here. How many flat screens were sold? 90. Good. To the others. Is that the 300? What is the 300? The 300 is the total that were sold, right? Because you got flat screen and you got non-flat screen, right? So it's 210. Good. All right, how'd you get 210? That's right, because if there was a total of 300 sold and only 90 of them were flat screens, how many were the other? That would be 210 would be the other. Does that make sense? So that was a little bit of a, not a trick. It's not really a trick, but it's a little extra thing that you had to do. It wasn't straight up going 90 to 300, was it? Right? And I would guess that probably some people went 90 to 300 on that one. But you got to read the instructions. Okay, the problem says find the ratio of flat screen to the others. So you had to find out how many were the other. Does that make sense? Where we got to 210? We went 300 minus 90. And now you can reduce this. Watch. This is easy to reduce. The zeros cancel out because 10 goes into both of them. 3 goes into both of these. 3 goes into that 3 times. 3 goes into that 7 times. And there's your ratio, 3 to 7. So that's how you do something like that. All right. The one on the test is actually easier than this. That's all I'll say about that. All right. But you will have one where it's a little bit of a word problem, and you do have to find the ratio. Make sure you reduce your fraction when they ask for you to find the ratio. All right. Everybody okay with that one? All right. Good enough. Number 3. Let's take a look at that one. I do not. Now, we had one like that on the quiz, but I do not have one like that on your test. All right, so that was nice, wasn't it? That's that one where you had to draw. Remember the one we did yesterday with the lamp post and the whatever that thing was. What was it? Yeah, what was it? The lighthouse. Remember the lighthouse one? You had to draw it all out. It was a word problem. You don't have to do that on the test. All right, so we'll skip number 3. Is that okay? All right, since it's not going to be on the test. All right. Number 7. Let's do number 7. Let's see if that's going to be on the test. You'll have, let's see. I don't actually have a quadrilateral, but there is a problem where you're going to have to find a ratio. So we might as well do this one. Okay, this is not that, it's not that hard. Because really, this works the same way with a triangle as it would with any. Let me try to draw this kind of like they do. Alright. And the next one's a little bit smaller, right? The second one's a little bit smaller. And do they twist it and flip it and stuff? Looks like they do. Looks like they just kind of reflected about the vertical. Yep. Is that what it looks like? Yep. Okay. And let's put some stuff in here. This is S and P. Now, on the test, you won't have a quadrilateral like this one, but the same kind of stuff holds true even if it's a triangle. So I don't mind doing this one, even though it's not a triangle. The same process is the same. Alright, and then they tell you this is 6.5. And it says find BC. We'll just make that X. Is that alright? Instead of calling it BC. And they tell you something. Now here's what's important. It looks like this is just stuff that they tell you and it's really not that important. But it is pretty important because it tells you which angles go with what angle. Okay, which angles are equal to each other. And again, the same thing holds true if this was a triangle. Okay, the same process would work if this was a triangle. Alright, this just happens to have another side, an extra side. So let's take A, B, C, D. So the A and the P equal each other. Alright, so let's mark it. The A and the P equal. The B and the Q equal. And that one right there. Everybody see that? It's just kind of flopped over, isn't it? The C and the R are equal to each other. This is R. And I'm not going to put 4 arcs. I'll just say that's one with no arcs, okay? Make it a little easier so I don't have to draw 4 of them in there. So how do I know what side goes with what? Well, look at this. Look at the 10. Which side over here does the 10 go with? Well, look at the 10. It's between the 1 and the 2 arc, isn't it? What side over here is between the 1 and the 2 arcs? The 6.5, right? So the 10 and the 6.5 go together. Now, you may not have had to go through all that. You might have just looked at it and said, oh, all they did was just flop it over. That side and that side are basically the same side, right? All right, and you could have done that, and that would have been fine. All right, but if you want to be real particular, if you don't really know what they did to it, if you don't know if they twisted it, flipped it, turned it upside down, or whatever, you can always look at where it shows up with the angles, okay? Because it's in between. This is the side that's between the 1 arc and the 2 arc angle. Well, this is the side that's between the 1 arc and the 2 arc angle. So those two have to go together. You with me? So we do a comparison. Does that mean they're equal to each other? Obviously not. That's 10 and that's 6.5. This is bigger than this one. But we can set up a ratio. And again, this works with triangles as well. So we go 10 over 6.5. Now what about the other two? What about this 28? What does that relate to? Well, that's between the what? It's between the 2 arcs and the 3 arcs. Come over here. Well, X is between the 2 arcs and the 3 arcs, isn't it? So the 28 and the X have to go together. Again, it's really not that hard on this picture to look at it and determine which ones match up. But, you know, if there is a problem where they're kind of hard to see what angles they're between, and they're the ones that match up. So I compared the big one to the small one. I'm going to compare it the same way over here. I can compare the big one to the smaller one. All right? That's all the geometry, and now you just do some math and cross multiply, and you're good to go. So what's that? 10x equals this, 28 times 6.5. Divide both sides by 10, and you'll just put that into a calculator. That's what I would do. So it's 28 times 6.5. That equals that. Divide that by 10, and there it is, 18.2. Is that the answer I read off to you? Yep, and that's BC, isn't it? It says find BC. I just made it X just so I wouldn't have to, you know, deal with 2 letters here. Just put 1 letter. All right? That's all there is to it. Now, again, you don't have one with a quadrilateral on the test, but you will have one that you'll have to do with triangles. You have to find out which triangles match up. They'll tell you the triangles are similar to each other, just like they did right here. They told you those those two quadrilaterals were similar to each other, that's really important because that tells you which angles are equal to what angle. Which angle over here is equal to which angle over here. That's very important. Don't just blow that thing off. All right? Just make sure that you know which sides go together. Because sometimes it might not be quite so easy to see here. Here it was pretty plain. I mean, there wasn't really any debate, I don't think, that these two went together and these two went together. Would you agree? Just by looking at it. But sometimes, especially with triangles, you're really not sure. Sometimes the angles look the same. Sometimes the sides look the same. You got to know what side is opposite what angle or in between what angle and all that kind of thing. We good with that? All right. So we done 7. Let's do 9 and then let's do 18. Let me write that down so I don't forget. My memory's terrible. All right, let's try number 9. Let me see if I give you something like this. I don't give you one exactly like this. I don't ask to find the perimeter, but let me see again. This is what, number 9 again? We do have one kind of close. I have one on the test where I actually tell you to find the perimeter. Oh yeah, that's what this says, isn't it? Yeah, I do have one like this. So let's do number 9. You'll definitely have one like this on the test, okay? So number 9 says, now again, this part right here is important, and they don't draw the picture for you on this one. And on the test, it's the same way. I don't draw the picture for you. You may have to draw the picture if you need to. You really don't have to, but sometimes it's helpful. You might just need this. This is really super important. Again, don't just blow this thing off. All right, this thing is telling you important information about your triangle. It tells you what angles are equal to what sides correspond to what. All right, so, and they tell you a bunch of stuff. Let's write down the stuff they tell you. They tell you AB is 12. They tell you AC is 16. BC is 20. And XZ is 24. Alright, this is all the stuff they tell you, and they ask you to find the perimeter. What does that mean to find the perimeter of something? What do we do? It's the distance around it, right? Find the perimeter of triangle XYZ. To tell you the truth, I think it might be a good idea to draw the triangles, okay? It doesn't have to be to scale. It doesn't really matter that it's to scale. Just draw just a regular old triangle. And then just draw another triangle that kind of looks like it. If I could grab these things, it's not that easy. There it goes. All right, I'll just put one right here. Is that all right? And let's make one smaller than the other one. So let's see, AB. Let's see, XZ and AC 16. So this one's actually smaller. This one with the A, B, and C is smaller, isn't it? Alright, so let's do this. It's ABC. And again, it doesn't have to be to scale. It doesn't have to be perfect. I just called one triangle ABC. Now, if I called this ABC, I'm going to have to call this one XYZ, and I got to put them in the same order. So where's the X going to go here? On top. Where's the Y going to go? Down there on the right. And then on the left is going to be the Z. Everybody see that? How did I know that? How did I know that that's where it's going to be? Because the A and the X have to go together, right? They have to match up. The B and the Y have to go together, this one and this one, and the C and the Z have to go together. So I had to draw those triangles on my own. It's not drawn for you on the test. It's not drawn for you on the worksheet, is it? So I think that's a good idea. You don't have to do that, but I think for most of us, I think it'll help. If I was to do this problem, this is probably what I would do. So let's put some stuff in here. AB is 12, so put a 12 right there. AC is 16. AC is 16. BC is 20. BC is 20. So they tell you all three sides of that triangle. Come over here. XZ is 24. XZ right there is 24. And they ask you to find the perimeter of this triangle right here. Okay? I'm trying to think of the best way to do this. I know the best way to do it, but I think that might confuse you because there is a relationship between the perimeters, because the scale factor of the perimeters is the same thing as the regular scale factor of the sides. I don't know if you remember that or not, but You just found, did you just find this and this? And then added them up?
Emily Bose, please report to the office. Emily Bose, please come to the office.
So you could find the perimeter of this and then set it equal to... Yeah, let's just do each one. That's what I figured. I figured it'd be easier to just do each one, okay? Let's use a different letter. Let's use, I don't know, S and T. All right? Or I guess since we're using your initials, we'll use a P right there. Is that all right? Okay. All right, so let's find S and let's find P. Once I find those two, I can add them all three together, and then I've got the perimeter. Does that make sense? All right, let's find the scale factor first. Like this 24. Which side up here corresponds to this 24? 16. So I'm going to find my scale factor. The scale factor is 16 to 24. Let's reduce it. Makes it a little bit easier. What number goes into both of these? What's that? 4. Okay, 4 goes into that. 4 times 4 goes into that what? 6 times, right? That still reduces though, doesn't it? So 2 over 3. Right. So the scale factor is 2 to 3. That's a little easier to work with than 16 over 24. Wouldn't you agree? All right. I hope you guys with your heads on your desk are ready for your test tomorrow, because I'm not kidding around. It is tomorrow. So so the scale factor is 2 to 3. So let's find what S is. So what we're going to do is this. We're going to go 2 to 3 equals what to what? 12 to S. Good. All right. I compared the little one to the big one, so I compared this little one to this big one, 12 to S. And now we can solve for S. So we cross multiply. 2S equals 3 times 12, which is what? 36. Divide by 2, S is 18. So that's 18. What is which one? This 2S.
Oh, 2S.
See, 2 times S. 3 times 12. All right, so S is 18. All right, that's good. Let's find what P is equal to now. So we use that same scale factor, right? We found the scale factor to begin with, so we go 2 to 3 equals what to what to find P? What is it? 20 to P. Good. 20 to P. And then we cross multiply again. So it's 2P equals 3 times 20, which is what? 60. Divide by 2. P is 30. So P is 30. Is that my answer, though? Do I write down S equals 18, P equals 30 for my answer? No, because what does the question say? Find what? Find the perimeter of this triangle. Now we know all three sides, so what do we have to do now? Just add them all up, right? So it's just 24 plus 18 plus 30, right? And that's a 12. That's a 3, 4, 72. And there's your perimeter right there. Make sense? That's probably the easiest way for you guys to figure it out. There is another way to do it, but we'll just do it like that. Good? All right. Was that the last one you asked about? No, 18, right? No, I don't have one like 5 on the test. I do see a couple problems on the test that are not on this worksheet, so we'll find one of those and do a couple of those as well. What are we doing? 18? Okay. All right, you got 3 parallel lines. You got one looking like this, and another one, then another one. It looks about like that, and that looks actually a little bit further away. About like that. All right. Let's just make that a little bit longer. That's good enough. All right, then you got a couple transversals. These are all parallel lines, so let's put the little arrows here to indicate that they're parallel lines. And let's do another color. You have a transversal about like that, then you got another one about like that. That's pretty close, right? And they say that this little bit is 8, this is 18, this is 2x minus 2, and this is 13.5. Alright. And you got to solve for x. Alright, well here's the deal. Now, did they tell you that this segment is equal to this segment right here? No, they don't. Remember we did that yesterday? We had that on the quiz, right? We had a couple questions on the quiz where these two are equal. This time those two are not equal to each other. So you can't just set this equal to this and then solve for x, because nowhere in here does it say. Because look, this is 8 and this is 18, so these aren't going to be equal to each other either, are they? All right, so what do we have to do, though? We can set up some ratios. And once you get used to setting up these ratios, it's pretty easy, I think, don't you? You could take this 2x minus 2 and compare it to this. If I compare them like this over here, what am I going to have to do over here? Go 8 to 18. Good. Or what's another possibility I could do? I could have compared 2x minus 2 to what? To 8, but then I would have to go what? 13.5 to 18. Good. All right, getting the hang of it now, right? You see that? So watch what we get. We get 2x minus 2. Let's do it like this. Compare it to 13.5. And you're going to set that equal to 8 over 18. If you wanted to, you could have simplified 8 over 18 if you want to. But let's just use a calculator for this and just put them all in. Cross multiply to solve for x, correct? So remember, look what I just did right here. What did I put on there that wasn't there before? Parentheses. I think that's very important that you put the parentheses there. So because we're going to have to distribute, right? And this is what? 13.5 times 8. And we'll put a lot of this stuff in our calculator. Well, you could distribute. You know what might be easier? I don't want to mess you up or anything, but watch. This 18 is being multiplied, right? How do we get rid of 18 if it's being multiplied? We do what? Divide, right? So I divide this side by 18, divide this side by 18. Let's see what we get. Anybody think about doing that? That might be easier than multiplying everything by 18 right here. Let's see. If it doesn't come out nice and pretty, maybe we don't want to do it. I don't know. So 13.5 times 8 and divide that by 18, right? So it's 108 divided by 18. Comes out to be 6. Oh, yeah, that makes things a lot easier, don't you think? Everybody see what I just did right there? Normally, we'd take that 18 and multiply it through. But I'm like, hey, wait a minute. 18's sitting out here. Why don't I just get rid of it right now? Just divide by 18. It would work either way. All right, I think this might be a little bit easier. Now the rest of it's a piece of cake, isn't it? Add a 2 to both sides. So 6 plus 2 is 8. Divide by 2. X is 4. And there's your answer right there. Is that the answer I read off? Okay, good. Always like to know if I got the right answer, even at this stage of my career. All right, it's nice to know. Add 2, so gives you an 8. Then I divided by 2. Right? If you want to show the work, feel free. I just didn't feel the need to. We good with that? All right. Let me see. I don't have anything exactly like that. I do have one on the test where the segments are equal to each other. Remember that? So if I told you that this was equal to this, then you would set these two equal, you solve for x. So actually, this is a little bit harder than what I'll have on the test. I actually made it a little easier when you have those 3 parallel lines cut by transversals. Isn't that nice of me? Yes. All right, let me find something that may not be on this worksheet. Do you remember that one where we had like the angles of a triangle and the ratio was, I don't know, remember the ratio of the triangles was like 2 to 3 to 5 or something like that. Remember that? And it said, okay, if the ratio of all 3 angles was 2 to 3 to 5, find each of the angles, right? Find the measure of the 3 angles. I think you had one on, did you have like one like that on the quiz? I think you did. Yeah, it was actually, I told you the perimeter of a triangle, right? But I could say the 3 angles. So this is actually 3 angles. So what do I do to find all 3 of the angles in my triangle? And this is the ratio of them. I don't know if this comes out even or not, but we'll do it anyway. I just made these numbers up. So what do? We take the 2 and do what? 2x. Good. Then what do we do? Plus what? 3x. Good. What? Plus 5x. Now what do we set that equal to? 180. How did you use 180? This is just one I made up. This is going to be on the test. All right. So these 3 add up to be 180 because that's what happens to 3 angles of a triangle, right? The angles of a triangle add up to be 180. All right. So that's what I do. And now you just work this thing out. 2 and 3 is 5, and 5 is 10, so it's 10x equals 180. This comes out nice. Divide both sides by 10, and x is what? 18. Is that my answer, though? Do I circle x and say, boom, there it is. That's my answer. No, it says find all the values of the angles. Find all the angles. So I plug it back in. Plug it in where? 2 times 18, right? Then I go 3 times 18, and then I go what? 5 times 18. And then I get those, and then that would be my answer. All right, that's 36. I don't know. What's 3 times 18? I should be able to do that in my head, but I'm too lazy. 3 times 18, that's 54. And then 5 times 18, 5 times 18 is 90. All right, and that would be your answers right there. Now, again, I just made this up off the top of my head, this 2, 3, and 5, but you'll see something very, very, very close to this on the test, okay? The numbers will just be a little bit different than 2, 3, and 5. Everybody see that? We set it equal to 180 because these are angles, 3 angles of a triangle. What if I told you the perimeter of the sides? What if I said this is the ratio of the sides and I give you a perimeter? You wouldn't set them equal to 180, would you? You'd set them equal to whatever the perimeter was. All right? And on the quiz, you had one where it said the perimeter. In fact, tell you the truth, I'm looking at the test right now. I have one like this, where it's angles, and then I have one where it's perimeter. So the only thing different is when it says angles, that's an angle symbol. I'll write the word out. Okay, when it says angles, you set them equal to 180. When it says perimeter, right? So if I told you the perimeter was, I don't know, 140 or something like that, 140 inches, then what would you do? You'd add these up and you set it equal to 140 instead of 180. Does that make sense? So use 180 when it's angles, and then whatever the perimeter is that they tell you, that's what you're going to set them equal to when it says find the perimeter of the sides. Got it? So you take those 3, you put an X next to each one of them, you add them up, you set them equal to whatever the perimeter is if it's a perimeter problem, or whatever, or equal to 180 if it's an angle problem. So you're going to have one of each. They tell you the perimeter. Okay, they'll tell you the perimeter, and then you just set it equal to whatever they tell you the perimeter is. Make sense? So you're going to have one of each of those. All right. Did that. We did that. Let's do one like, find one. Let's do one like 11, down the bottom of page 61 of your worksheet. You're going to see something that kind of looks like this. And I think you had one like this on the quiz, I think. Can't remember exactly. Looks like that. Looks like that. And then this one goes to here. Alright, that looks like number 11, doesn't it? And then this is, what, 15. This is x. This is 6. This side is 2x plus 4. This side right here is 2x. Is it plus or minus? Minus 4. Because I see better close up without my glasses. I can't see, it's all blurry. I have contacts too, but they only work about this distance, and sometimes I don't know, when I'm that far away I can't see, but when I go like this I can see better. It's much more clear. Alright, and here's what they do. They tell you this angle is equal to this angle, and that's all they tell you, and they ask you to solve for x. So you're going to have something like this on the test, something like it. They could have told you this. They could have told you that this side was parallel to this side. It would be the same exact problem, right? So if this side was parallel to this side, these two would already be equal to each other, right? But they don't tell you they're parallel. They just say that this angle is equal to this angle. What else can I say? How do I know that they're similar triangles right now? Well, what if I said this angle would equal this? And I know that just by looking at it. How do I know those two angles are equal to each other? Because they're what? Give me the name of it. Starts with a V. Vertical. They're vertical angles, right? They're vertical angles. So now, what do we do? How in the world do I know which one goes with what? Like this right here. How do I know what I'm going to compare x to over here on this side right here? Well, let's see what angle it's opposite. What angle is this x, this side x right here? What angle is it opposite? The one with one arc. Do you see that? See, it's across from this. Look over here. Which side is opposite the angle with one arc over here? This 2x minus 4. So the x corresponds to the 2x minus 4. Does it mean they're equal to each other? No. This one's way bigger than this one. They're not equal, but they correspond to each other, so we set them up as a ratio. So I compare x to 2x minus 4. Right? This whole test is doing this kind of stuff. If this is completely foreign to you, you better do some studying. You better watch some YouTube videos. Okay? And with all you guys with your head on the desk, I just don't get it. I just can't understand why you would have your head on the desk right now. But, you know, that's up to you, I guess. So I compare this side to this side. Now, what else am I going to compare? Yeah, probably this one to this one, right? How do I know for sure that they actually correspond to each other? Look at 15. 15 is opposite the angle with no arc. And then you come over here, 6 is opposite the angle with no arc. So they definitely go together, don't they? So that equals 15 to 6. Now you could just cross multiply right now. But you know what might make your math just a little bit easier? Look at 15 over 6. What do you think you could do with that? 3 goes into that 5 times. 3 goes into that twice. That makes your math just a little bit easier, don't you think? Yeah, I'd rather multiply by 5 than multiply by 15. It would still work out in the end the same, but I think it's easier this way. So let's cross multiply. So x times 2, which is 2x, equals, now watch what we have to do. I'm multiplying 5 by this whole thing. So I have to distribute. So it's 5 times 2x minus 4. I'm going to write it down so I don't forget to distribute. You could have just done that in your head, right? You could have just distributed right here, then wrote it down. But I'm going to write it down so we see exactly what we're doing here. So now go ahead and distribute. So that's going to be 10x, and this is going to be minus 20. Subtract 2x from both sides. I'm going to add a 20 to both sides. Forgot to show the minus 2x there. Okay, so that cancels. That cancels. I get a 20 over here. 10x minus 2x is 8x. Divide by 8. And x is whatever that is. What's 20 over 8? Let's see. 2 goes into both of those. Actually, 4 goes into this, right? 4 goes into that 5 times. 4 goes into that twice. 5 over 2. And you could have kept it like that. I would be okay with that. But I'm sure many of you are going to put that into a calculator, even though you don't need to. But what's 5 over 2? It's 2.5, isn't it? I think that's what I read off to you. It's 2.5. But you could have written it 5 over 2, and that's perfectly fine. You could have put this into a calculator and got 2.5, and that's okay, I guess. All right, but I think that's lazy. I think you should just reduce it, get 5 over 2. And if you want to write it 2.5, you can, but you don't need to. All right. So you'll see something like that on there. Like number 4. No, I don't give you any words like that where you have to work it out. So don't worry about 4. I'm looking at 6. Did anybody ask about 6? Let me see. Pretty sure you'll have something very close to it. Yeah, like look at number 4. You'll have something kind of like, I'm sorry, not number 4, number 6. Number 6, right? Let's go with this tan color. We never use that color. So number 6. Let me draw the picture. Oh, we're running out of time, aren't we? Yeah, I gotta do this real quick. Boom. We did this the other day anyway. Probably yesterday, I think. Right? And this is 1.8. This is 6. And this is 2.4. 2.4. And we have to find CD, which is this whole thing. Remember this one? Remember I said that was probably the hardest one on the quiz the other day? All right, so what are we going to compare? We'll call this X. So look what we're going to do. Actually, and these are parallel. Could actually do this a couple different ways. Let's just do it like this. Let's compare. Nope, let's do this. Let's find this little thing right here, and then we just add it to the 1.8, and then we got the whole thing. All right, so let's do that. Now watch. Since these are segments of these two sides right here, I don't have to compare the whole thing. I can just do this. Watch. I can go y to 6. Watch. If I want y to 6, what am I going to have to do here? 1.8 to 2.4. Everybody see that? Now, I'm not going to do the math because we're about to run out of time. Cross multiply, solve for y, and whatever you get for y, what are you going to do to get x? Just add it to the 1.8, right? So you might see something like that. So test tomorrow, chapter 7. I've given you a nice review. I'll let you hang on to that review sheet until tomorrow. Turn that review sheet in tomorrow.
To the office at this time, Jane